All right, guys, so this is a review of us solving equations by, we identified a solution of the equation from the list given. That's the instructions here. So this is where we are given a list, or you can call it a solution set. And we have to determine which of those numbers or which number is the solution that makes the equation true. Remember, an equation is where we have two expressions set equal to each other. So this expression here, a plus 15, that has two terms, a and then a plus 15. And then over here, after the equal sign, is another expression. It just has the one term, a 23. So we have to see which one of these numbers will make, if we substitute it for a, will make this true, where 23 on this side will equal 23 on that side, all right? So this first one was done for us. Notice they said, okay, let's try the first number, 6. Try 6. So we substitute in 6. 6 plus 15. Hey, that's 21. It does not equal. Remember this symbol when you have an equal sign and a little slash in it? That means that it does not equal. So we know that 21 does not equal 23. Then when we try 7, we substitute that 7 in for a. 7 plus 15. Well, guys, that's 22. And 22, again, does not equal 23. So now when 8 is tried, 8 plus 15 equals 23. Notice that is correct. 23 does equal 23. So we have our check mark next to that. So I know they just put 8 on the line, but I like to make sure that we said that 8 is what a equals. All right, so let's look at number 21. Number 21 says 19 equals p minus 12. And I don't want this to get you caught up because now the equal sign is over here. Either way, we still have two expressions being set as equal to each other, regardless of what side of the equal sign those expressions are on, all right? So let's look at this. They give us three numbers, 29, 30, and 31. 29, 30, and 31. So let's go ahead and try 29. So we know that it's saying 19 equals p, and I'm going to substitute. So I'm putting my parking space, as we like to call it, all right, minus 12. And I'm going to park that. We're trying 29, so that's what I'm putting in there. And so now I'm going to solve this side. And 29 minus 12, and that's a pretty quick one. But let's say you needed to pop that into the calculator. Guys, that's 17. All right. So 17, does that equal 19? No. So I know that it's not 29. Let's try 30. 19 equals, put our parking space with that 30 minus 12. So now I am going to solve this side here. 30 minus 12. Let's pop it into the calculator. Ah, look, guys, it equals 18. Does 18 equal 19? No, it doesn't. So I am done there. I know that it is also not 30. So by process of elimination, we can say, yay, it's 31. The reason I say to go ahead and check every single time and to check all of them, because sometimes it could be asking you if any of these are a solution. You don't want to automatically assume that the last number on that list is a solution because maybe none of them make it true. So let's go ahead and plug in our 31 and check it. So 19 equals 31 minus 12. Let's go ahead and pop that 31 minus 12. And looky, looky, we got 19. Does 19 equal 19? Indeed it does. Put my check mark. And now I know that when I substituted in 31, that was what made this equation true. So my P is equal to 31. All right, let's look at number 22. 63 equals 9K. 63 equals 9K. So let's go ahead And this one, you could do mental math, right? 9 times what number equals 63? Pretty easy. But let's go ahead and identify the solution using our substitution. So we have 63 equals 9 times a variable. We are going to try 6 first. All right, and 9 times 6. This is a simple one, but let's pop it in the calculator. Look what we get, 54. Does 63 equal 54? No. So that's not a solution to make that true. So now let's look at 7. We're going to substitute in 7. 63 equals 9 times our 7. So now I'm going to put 9 times 7 into the calculator. We get 63. Does 63 equal 63? Indeed it does. So that means I know that 9 times 8 is not going to give me 63. All right. So I can eliminate that. And if you wanted to check, just to be sure, 9 times 8 is 72. All right, so I now know that K is equal to 7. That's what makes this equation true. All right, so now let's get a look at number 23. Let's look at number 23. 36 divided by S equals 4. 36 divided by S equals 4. So that means when I take 36 and I split it up or by whatever S equals, I'm going to be left with 4 groups, okay? So let's see. Let's go ahead and try. We are given the numbers 9, 10, and 11. So let's try 9 first. 36 divided by, I'm going to put a parking space there. I'm going to park that 9 in there. And it should equal 4. If it's true, okay? So let's go ahead and take a look. 36 divided by 9. Look at that, it's 4. Does 4 equal 4? Indeed it does. So now I know that that's correct. My S is equal to 4. I found out the solution. All right, guys. So hopefully this has been helpful and you will continue. You can look down here and see these equations, these mental math problems. These should be pretty simple for you. But let's go ahead and let's look at number 30. All right, these are some word problems, okay? These are some word problems. Number 30 says, Gabriella made 36 cookies. She gave away 28 cookies. Use the equation 28 plus C equals 36 to find C, the number of cookies that she kept. All right, so it says in the instructions that you can solve using mental math or the guess, check, and revise strategy. Some of you have figured out that, well, if she made 36 cookies, she gave 28 away. I could just say 36 minus 28 in order to find out what she had left. So let's go ahead and let's try that. 36 minus 28 leaves us with 8. So that means it would be 8 cookies that she kept. All right. So we're saying that C, the cookies that she kept, equals 8. Let's check that. Let's make sure. All right. So we have 28 plus, in our parentheses, equals 36. And we said that C equals 8. So that's what we're parking there. So now let's solve this side. 28 plus 8, 36. So we're saying that 36 equals 36. And that is absolutely correct. So find C, the number of cookies she kept. C is equal to 8 cookies. All right, guys, go ahead and finish up this worksheet.